Hello everyone. Today in this video let us discuss about the relationship between zeros and coefficients of a polynomial. In this we will discuss about the zeros of a linear polynomial, zeros of a quadratic polynomial and the zeros of a cubic polynomial. The relationship between zeros and the different type of polynomials. Let's start with a linear polynomial. So for a linear polynomial, the general form of the linear polynomial is ax plus b. General form of a linear polynomial is ax plus b. So for which values of x this linear polynomial would become 0 is called the 0 of this polynomial, right? So for that we get by substituting ax plus b is equal to 0, ax is equal to minus b and x is equal to minus b by a. That means here minus b by a is called the 0 of this polynomial for which this linear polynomial would become 0. So this is only the relationship between the coefficients and 0 of this linear polynomial. 0 of this linear polynomial is nothing but coefficient of minus constant term by coefficient of x. So this is the relationship between coefficients and the 0 of this linear polynomial. Now let us find the relationship between zeros and coefficient of a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c. So this is the general form of any quadratic polynomial with the highest degree of 2. Now to find the zeros of this polynomial, let's take an example of this quadratic polynomial. Let the polynomial px may be 2x square plus 5x minus 12. So let us find the zeros of this polynomial. To find the zeros of this polynomial, we need to factorize this polynomial first and then find the zeros of this. So let us take, to factorize this, let us use the middle term, splitting the middle term model method. So let us take the first term and last term and multiply and find the factors for that. So minus 2 into 12 minus 24. Let us find the factors of 24 such a way that if the integers are added, you will get the middle term, right? We know that model already learnt in 9th class, right? So minus 24 factors may be plus 8 with minus 3 multiplied. So if we add these two integers, we'll get plus 5. So let us write the quadratic polynomial as 2x square plus 8x minus 3x minus 12. Now take common for these two and write 2 as common. 2x as common, x plus 4, and in the last two terms take minus 3 as common, we get x plus 4. So which we can write like which is equal to 2x minus 3 into x plus 4 are the two factors for this polynomial. So this polynomial would become 0 if any one of these factors is 0. So let us equate the factors to 0. So which is equal to 2x minus 3 equal to 0 or x plus 4 is equal to 0, from which we can write x is equal to 3 by 2 or x is equal to minus 4. So we got the zeros of this quadratic polynomial, which is 3 by 2 and minus 4. So now let us find the sum of the roots or sum of the zeros. Sum of the zeros of this polynomial are 3 by 2 plus minus 4, which we can write as minus 4 by 1, and we can write it as 3 by 2 plus minus 8 by 2 into 2 into 2. If you do here, you will get minus 8 by 2, which gives you minus 5 by 2. So if you observe carefully this minus 5 by 2, minus 5 is nothing but the middle term coefficient. X coefficient is plus 5 actually. So we can write this minus 5 as minus coefficient of x. Minus coefficient of x by 2 is nothing but the coefficient of x square. So which is equal to coefficient of x square. So we understood that sum of the zeros of any polynomial, quadratic polynomial is nothing but minus coefficient of x by coefficient of x square, which is the relationship between the coefficients and the zeros. Okay. Now if we do the product of zeros, now let us see the product of zeros. So if we take product of zeros here, multiply the zeros, minus 4 multiplied with 3 by 2, where you can do simplification. On simplification you will get minus 6 by 1, which we can also write it as into 2 into 2 if you write minus 12 by 2. So which is same as, if you observe again from the question, here minus 12 is nothing but constant term. So which is nothing but constant term by 2 is nothing but the coefficient of x square again. So coefficient of x square. So this is the relationship between product of zeros and the coefficients. Coefficients means even constant term is also. Okay. Now coming to in general, let us write now in general, if alpha and beta are the symbols used for zeros of a polynomial, zeros of quadratic polynomial in general. Generally, if we take alpha and beta are the symbols for zeros of the quadratic polynomial, then we can write it as alpha plus beta, which is the sum of the roots, which is equal to, now a common formula for this to find the sum of the roots, coefficient of x by coefficient of x square, which also you can write as minus b by a. Minus b by a. Minus b is the coefficient, b is the coefficient of x. So minus b by a is the coefficient of x square. And alpha into beta, the product of the roots is nothing but, as we seen, constant term by coefficient of x square. So which you can write as, constant is represented by, when you compare this with the ax square plus bx plus c, this is the polynomial, quadratic polynomial. You can understand that constant is c by coefficient of x square is a. Okay. So this is the common formula for finding the sum of the zeros or product of the zeros. And also this is only the relationship between the coefficients and the zeros of this quadratic polynomial. Now let us find the relationship between zeros of a cubic polynomial and the coefficients of the cubic polynomial. So let us take cubic polynomial now. The general form of a cubic polynomial is ax cube plus bx square plus cx plus d. This is the general form of a cubic polynomial. So now we are going to find the zeros of this cubic polynomial, for which the values of x that makes the polynomial as equal to 0. So by taking an example for this cubic polynomial, let us take an example. Px is equal to x cube minus 7x square plus 14x minus 8. So this is the cubic polynomial for which this polynomial would become 0 is, if you substitute in the place of 1 you will get 0, and if you substitute in the place of x you will 2, also you will get 0, and if you substitute in the place of x, if you substitute 4 also, it would become 0. So the zeros of this polynomial are, actually finding the zeros of this polynomial is not important for this class, only the relationship we need to find. The zeros of this polynomial are, for which values it became 0, 1, 2 and 4. Now if you take these as, like in general, the zeros of this polynomial as alpha is equal to 1, you think, beta is equal to 2, and gamma, the third zero, let us represent as gamma, which is 4. So let us represent the zeros of the polynomial as alpha, beta and gamma. So where alpha is 1, beta is 2 and gamma is 4. Now we are going to find the sum of the roots. Sum of the roots, I mean sum of the zeros otherwise, is equal to alpha plus beta plus gamma is equal to 1 plus 2 plus 4, which is equal to 7, which I can write this 7 as minus of minus 7 by 1. Why, I'll tell you. So if you compare this with the general form, a is equal to 1, here I'll write a is equal to 1. If you compare b is equal to minus 7, and if you see c here, compare c is equal to 14, and d, the constant term, is equal to minus 8. So if I could observe this and write minus of minus 7 is nothing but b, so minus b by 1 is nothing but a. So minus b by a is the relationship between sum of the zeros and the coefficients. So, or you can also write coefficient of, which we can write as coefficient minus negative coefficient of b is nothing but x square. Coefficient of x square by a is nothing but coefficient of x cube. So sum of the roots or sum of the zeros of the cubic polynomial is given by minus coefficient of x square by coefficient of x cube. Now let us find the product of the roots. Let me show you here up to here so that we can have the values of a, b, c, d here. Now let us take product of the two roots, product of the zeros, which is alpha into beta into gamma, which is equal to 1 into 2 into 4, which is 8, right? So this you can write as 8 again, minus of minus 8 by 1 I'll write. Why? Because you can write it as, now if you compare with the values of a, b, c, d here, minus 8 is nothing but the constant term. So negative constant term, I'll write it as negative constant term by 1 is nothing but coefficient of x cube. Coefficient of x cube. So product of zeros also can be written as minus d by a. Minus d by a. D is the constant. Okay, this is the formula for product of zeros for a cubic polynomial, which we can have another rule also, another relationship here, which is nothing but, this is the relationship between product of zeros and the coefficient, and we have another relationship also here. So consider the sum of the product of zeros taken two at a time. What? Consider the sum of product of zeros taken two at a time, like alpha plus alpha into beta plus beta into gamma plus gamma into alpha. So we are taking the sum of the products of each taken two at a time. Okay, now we are having the values of this when substituted, 1 into 2 plus 2 into 4 plus 4 into 1, as alpha, beta, gamma are 1, 2 and 4. So we get the answer as 2 plus 8 plus 4, which is equal to 14. Again, this 14 I'll write like 14 by 1. So where 14 is the coefficient of x. Wait, 14 by 1, which is equal to 14, let us compare with the values. Let me once go through this. Yeah, 14 is C. So C is nothing but coefficient of X. Yeah. So 14 is coefficient of X. Let's write coefficient of X by coefficient of X cube. So which we can write as C by A. So this is one more relationship